The word significant refers to something meaningful or important. Significant figures tell us how many of the digits are certain, coming directly from the instrument, and the last estimated digit as well. There are 3 easy to follow steps when counting significant figures. Step 1, from the left, always go to the first non-zero digit. In this example, we would start counting here at the 1. Step 2, all digits that follow are significant, except the uncertainty of zeros on the end of whole numbers. Our example is not a whole number, so all remaining digits are significant. We have 6 significant figures. This is usually abbreviated to 6 sig fig. And step 3, zeros on the end of whole numbers might be significant. Further details would be required. In this example, we definitely have 2 significant figures, the non-zero digits. But there could also be 1, 2, or 3 of the zeros on the end that are also significant. We can't tell yet until we are told the precision of the measurement or any rounding that has been applied. Pause the video if you'd like to try these on your own first. In number 1, all 4 digits are significant since there are no zeros, and similarly in number 2. In example 3, we see the same 4 digits, but this time with a leading 0, which is not counted as significant, so there are still only 4 significant figures. In number 4, there are more leading zeros, which we can still ignore, but the extra 0 on the end of the decimal makes it more precise, giving us 5 significant figures. In number 5, all 4 are significant, remembering that zeros in between non-zeros are significant. In number 6, it's a special case. Zeros are on the end of a whole number. No further details are provided, so they may or may not be significant. We cannot tell for sure. We can say that it definitely has 2 significant figures and might have 3 or even 4. If we were told that it is correct to the nearest 10 here, then we would know it has 3 significant figures. In examples 7 and 8, we have decimals, so we ignore the leading zeros, but everything else is significant, giving us 4 significant figures in both cases. Now that we know how to count significant figures, we need to be able to round our answers to the required number of significant figures after performing various calculations. The good news is that the technique is the same as rounding decimals, or whole numbers, except that we look at the digit after the required number of significant figures instead of decimal places. So we round up if the next digit is 5 or higher, otherwise we leave it as it is. Either way, we discard all the extra digits unless it's a whole number, in which case we change the extra digits into zeros. These will be place value holders and are zeros on the end of a whole number that we know will not be significant. This is why we should state the number of significant figures after our answers, so other people will also know. Consider this calculator display. Assume we need to round our answer to 3 significant figures. Here are the first 3 significant digits. We simply need to decide whether they remain as they are or whether the last digit will go up by 1. Our rounded answer is either 4.17 or 4.18, whichever the displayed value is closest to. Clearly it is closer to 4.18, but looking at the next digit, we see it is a 6. So being 5 or higher, it tells us to round the 7 up by 1 to an 8. It's good practice to state the rounding that has been applied when giving your final answer. In this display, the third significant figure is a 0, and the next digit is only a 4. So we are less than halfway from the 0 to the next possible digit, a 1. So we leave it as it is. The number is closer to 0.0580 than it is to 0.0581. Let's round our earlier examples so they only have 3 significant figures. In the first one, the first 3 significant figures are here. This 8 makes the 6 change into a 7. We can't discard the last digit since it's a whole number. 517 is not even close to 5,168, so we need to change it to a 0. Our answer is 5,170, correct to 3 significant figures. Clearly, the original value is closer to 5,170 than it is to 5,160. In example 2, we have the same digits, but this time it's a decimal, so we can discard the extra digit, giving us 5.17. The same goes in number 3, so the answer is 0.517, and number 4 gives us 0.00517. Number 5 is a whole number again. The 8 forces 0 to become a 1, but we need to replace the 8 with a 0, giving us 5,110 to 3 significant figures. Example 6 already has 2, 3 or 4 significant figures depending on whether or not the zeros on the end are significant. With 3 significant figures, the first 0 will be significant, but the last one will not be. Stating 3 significant figures after the answer clarifies this for anyone reading the solution. In number 7, the 0 after the decimal is the 4th significant figure. Removing it gives us 3 significant figures. Similarly, in our last example, the extra 0 on the end needs to be truncated, leaving these 3 as the significant figures. Here are some examples for you to try. Round them to have only 2 significant figures. The first becomes 21 since the 2 is clearly less than 5. In number 2, we have 3 digits but require only 2 significant figures. The 4 means that we do not round the 2 up, we leave it as it is. However, we need to place a 0 where the 4 was. In other words, 324 is closer to 320 than 330. Without the 0, it would look like 32. Next, the 2 significant digits are the 1 and the 8. They are followed by a 6, so we round the 8 up to 9, giving us 0.019. The next one is very similar, except it is a 9 that needs to be rounded up. It's probably easier to think of it as being 19, rounding up to 20, giving us 0.020. Number 5 becomes 0.38, since it's only a 1 that is the next digit. In example 6, the 4 and the 9 are our 2 significant digits, but the 7 after them makes the 9 go up by 1, in turn making the 4 go up to 5. It's easier to think that 49 goes up to 50. We also need all these zeros to hold the place value columns of the other non-significant digits, giving us 500,000 to 2 significant figures, which is to the nearest 10,000 in this particular example. Next, the first 2 9s are significant, followed only by a 1, so they remain as they are. And lastly, again with 2 9s, but this time followed by a 5. We need to think that 99 rounds up to 100. However, this gives us 3 significant figures. We only want 2, so we need to drop the extra 0 from the end of the decimal, giving our answer as 0.0010.